Hi, everybody. Well, I don't think I need to tell you or convince you that online misinformation has been a problem during the pandemic. So, in my research, I've been developing computational techniques to trace and monitor online misinformation at scale on all sorts of social media, from Twitter to Reddit to bad places like 4chan and whatnot. However, most of this research, my own as well as one by the community, has focused on text. That's because we have decades of research on natural language processing and we know how to do it very efficiently and so on. But a lot of misinformation actually is carried out through images because they are more immediate, they convey more complex messages, and people just like to share them. The problem is that image processing techniques tend to be very computational intensive. So we cannot really scale up image processing techniques to hundreds of millions of images or billions of images and so on. Instead, what we would need are techniques that allow us to group images together, images that look similar. And if we can group together all images that look similar, then we can just pick one and apply more analysis on that. So that's what I've been doing in this project. So we ran a pilot where we collected Twitter data, COVID-related Twitter data. We downloaded all the images posted in those tweets, and then we applied a technique known as perceptual hashing. So basically, we take an image, we break it up into quadrants, and then for each quadrant, we calculate a hash, a number basically, and we convert basically an image into a vector. And then we can do all sorts of vector comparisons that we know how to do very efficiently. And basically, the idea there is that images that have a similar perceptual hashing will look similar. And so we can group together images that are not only the same image being shared over and over, but they are variations of the same image, like memes and things like that. And then suddenly, instead of having hundreds of thousands of images, we have a few thousand. And we can either apply more complex analysis techniques on them, or just have grad students look at them and figure out, which ones are misinformation and which are not, which is what we did in this preliminary study. And so what we find 6 broad categories of COVID-related misinformation. We see, racism against Asians. We see conspiracy theories. We see wrong medical advice, people advocating for hydroxychloroquine or ivermectin or all these kind of things that you know very well about. But what these tools allow us to do now, we can find all the tweets containing a certain image, and then suddenly we can start measuring what kind of images go viral and how long are they discussed for and all these kind of things. And so what we find is that essentially tweets containing misinformation images are not shared more than tweets containing other kinds of images. So the images that are the most popular on social media are actually, cat pictures or funny memes and things like that. So if we develop a technique to identify misinformation that's only based on virality, we will miss a lot. Instead, what we find is that these tweets containing misinformation images are discussed for longer periods of time. So if we want to develop a comprehensive strategy to identify misinformation, we should actually look at the lifespan of these tweets instead of how viral they are. And yeah, these are just preliminary results, and we just submitted a paper about this, but I'm going to work more on this topic, and I'm happy to discuss it with anybody at the reception. Thank you.